Okay, welcome back. Okay, good morning, everyone, again. So, after calculating y2 value, you are getting the same value y2. It's 13.66 meter. Okay. So next we need to find out the height of the jump. Okay. So height of the jump is nothing but the difference between the depth. So y2 is the depth after the jump, and y1 is the depth before the jump. Okay. So if we subtract, we will get the height of the jump. Okay. So y2 value is 13.66 minus y1 value is 1.88. Okay, 1.8. So you're going to get around 11.86 meter. Okay. So then after that you need to find out the length of the jump. You see, length of the jump we have two expression. One is 6.9 hj, one is 6.1 hj. Okay. So here the condition is if your fr1 is greater than 5, you are going to use 6.8 6.1 hj. Okay, or if it's less than 5, then we are going to use this one. So here in our case, in this numerical, we got fr1 greater than 5, so we are going to use 6.1 hj, or you can say 6 hj. Okay, it's up to you. Okay, so length of the jump will be 6 times of height of the jump. Well, he gets around 71.18 meter. You will get around 71.18 meter. Okay, so then next we need to calculate the loss of energy. Okay, so loss of energy is nothing but y2 minus y1 whole cube divided by 4 y1 y2. Okay, so this is the expression. The derivation we have already discussed about this expression. Okay, so we are going to use here to find out the loss of energy. So y2 value is 13.66, y1 value is already given, I think it's 1.8 meter, and you can find out the delhi. And see, you are getting the same value or not. 16.96 meter of water, that's loss of energy. Okay, very good. So next we need to find out the efficiency. Okay, efficiency is nothing but your E2 divided by E1. That is energy, specific energy after the jump divided by specific energy before the jump. So you, in this efficiency part, you first find out the E1 value, and again you find out the E2 value separately, and then you divide. Okay, E2 divided by E1, you will get the efficiency. So this will be your Y2 plus V2 square divided by twice G, and for E1 also, for E1 equal to Y1 plus E1 square by twice G. So you separately find out the specific energy before the jump and after the jump, and then you divide and you find out the efficiency. Okay, and check if you are getting the same value or not. It's around 45.5%. V1, velocity of 1 is already given. Okay, V1 value is already given, that is 24. Okay, velocity of V1. Okay, now if you want to find out the V2 value, you can do one thing. You can use this expression I2, okay, is equal to half minus 1 plus root over 1 plus 8 FR2, okay, FR2 square. Okay, so from this equation your y1 is already known, I think it's 1.8. Y2 value you have already calculated, I think 13 point something, I don't remember. Okay, you can find out the y2 value, then half, then again fr2. So only unknown is fr2, so you can find out the fr2 easily from this expression. Okay, you can find out the fr2 value, and then we know fr2 is nothing but your v2 divided by, sorry, divided by root over g y2. Okay, so if fr2 is known, g value we all know 9.81, and y2 value we have already calculated. You substitute here, you can directly find out the v2 value, that is velocity after the jump. Okay, so you can use this expression. Okay, you can use this expression first to find out the fr2 value, substitute here in this equation, you can find out the v2 value. Okay, and v1 is already given, that is your 24 meter per second. So your efficiency will be approximately 45.5%. So how much you are getting v2 value? How much you got v2 value? 0.332, sorry, 0.322 meter per second. Okay, and efficiency you are getting the same, 40.5%. Yeah, 0.32 is too less. I think here, let's see. So how much you got the efficiency? 43.75. Okay, fine. Okay, fine. 45.5%. Very good. Okay. So next we need to identify the type of jump. Okay. Next we need to identify the types of jump. So that types of jump, if you remember, we determine the types of jump based on two categories. One, the FR1 value, and another one is efficiency, if you remember. Okay. So the condition is if our FR1 value is more than 5, is greater than 5. Okay. I think it's 5 point something. Okay. So that means our FR value, FR1 value is greater than 4.5 and less than 9. Okay. If your FRN value is greater than 4.5 and less than 9, then our jump is steady jump. Okay. You don't remember, you have to go back to the types of jump. Okay. So here, if you see, for steady jump, your FR1 varies from 4.5 to 9. Okay. Your FR1 varies from 4.5 to 9 for steady jump. Okay. And efficiency also it's from 45 to 70%. So we got an efficiency of 45.5%. So it's a steady jump. Okay. So if greater than 9, then it is a strong jump. If it is less than 4.5, then it is a oscillating jump. If it is from 2 to 2.5, sorry, 2.5 to 4.5. Okay. So in our case, our FR1 value is greater than 5. Okay. So that means it is in steady jump. Okay. So here is jump is steady. Okay. Then we need to find out the ratio. I think we have already calculated FR1 value and FR2 value also we have already calculated. You just find out the ratio. See, you will get around 20.85. Over. Oh, it's okay. Then here we are. So take your time. No issue. Okay. This is the last thing we need to calculate. That is your ratio. FR1 divided by FR2. We'll do one thing. We end this meeting here, and next class we solve another one numerical similar to this, and then we move on to our last unit. Okay. This unit is almost it's completed. Okay. Or only as we have lots of time, so we solve one more numerical related to hydraulic jump, and then we move on to our last unit. Okay. Thank you, students.